that you had a bonus last night, and a lot of you were able to do it, right? What was your thought process when you did the antiderivative of the one on the homework was cosine or sine? This was cosine. What's your thought process when you're doing an antiderivative of cosine 3x minus 2?
First, you have to do the cosine, you can change it to like sine.
Okay, the function that has cosine as its derivative is sine. The inside would have to stay the same. However, if I take the derivative of sine of 3x minus 2, I don't get cosine of 3x minus 2. I get cosine of 3x minus 2 times 3. So how could I compensate for that? So we're going to learn how to do that today a little bit more systematically, especially if it were more complicated and you couldn't see it. If you can see it, do it, right? Just go for it. However, there will be a lot of times that your brain can't handle all of that at once. So we're going to look at a method for working with some chain rule problems. Some quotient rule, some product rule. Because there is no product, quotient, or chain rule that works for integration, we must use other mathematical techniques to find the antiderivative. One of those techniques is called the substitution method. In calculus AB, this is the only integration method they learn. This is where you stop as far as integration goes in AB. We will learn some further techniques in this class. Not in this chapter, we won't do it all at once, but we will learn some further integration techniques. But this is where AB calculus stops, is with the substitution method. You must use the substitution method anytime you're doing an integral, and you have two functions multiplied together, two functions divided, a function other than our plain x inside another function. So anytime you have a chain rule, product rule, quotient rule, you have to do substitution. Now, if I were in AB, I would say that's the only thing you have. That's the only option you have. You will later have some other options if substitution doesn't work. But substitution would be your first try. So, what we're going to do is we're going to let u be the more complicated function. Could be the thing that we're multiplying by, could be the inside of the function, could be the denominator, could be a numerator. But we're going to let u be some complicated portion of the function. We're just going to call it u. We're going to find the derivative of that u. We're going to solve for dx. We're going to substitute u and du in for x and dx. We're going to do a clever change of variables. That's what we're going to do. If you did it all correctly, all the x's will disappear and cancel. You will do the integral with only u's involved. Then you'll change back to x's. And don't forget plus c. This is our method. That's it. Again, yes, we could do the bell ringer without it, but there's some we won't be able to. So we're just going to use the method on the bell ringer, show you that it works, and then go to other problems. So I'm going to let u equal the inside of the function or a complicated portion of the function. So what would you call show you as I go. But I'm going to find the derivative of u. I'm just going to call it du, and I'll show you where I put the dx. I'll show you why it's the same thing. What is the derivative of that function with respect to x? 3. I'm going to put the dx on the other side. Just saves you a little time. See how it's just multiplied over. Any questions so far? Any questions so far? The dx. Du over dx. Okay. At first, it'll save you a step. If you don't like it, right, do dx and then multiply before dx.
So you just stack the dx on the other
side. Here's why. I'm going to replace the dx and the x, or the 3x minus 2 with u's. To see that, I'm going to solve for dx. That's why I already have it on this side. Just save you a step. If you don't do that, it's fine. Then you'll solve for dx. So I get 1/3 du equals dx. Does everyone agree?
So you can get that dx from the side on this side. Because like it's u, and then whenever you did the derivative, it was just u dx.
That's the derivative of u with respect to x. And then I'm multiplying the dx. Okay. Any questions so far? I'm going to get dx by itself. Then I'm going to go back into the original function, and I'm going to do substitution. The place where I see the 3x minus 2, instead of putting 3x minus 2, I'm going to put something else. U. And instead of dx, I'm going to put 1/3 du. Would you agree that is a much simpler integral? Yeah, this is an integral with respect to u. I can take the 1/3 out in front, can't I? What's the antiderivative of cosine of u? Sine of u, and then the 1/3 just kind of hangs out in front, right? And then step 7. Replace the u's back with x's. Was it 3x minus 2? Did we get the same thing that we got thinking it through? It was wonderful. I would really think this will through, right? It was faster. But we will need this technique for the ones who can't do it right. Any questions about the technique, how it works? Let u be the complex portion of the function. Find du, replace dx and put the u's in for the dx and the u. And then do the integral and then put x back in. That's the process. The hard part's deciding what to make u. So we're going to try a few. Some of them are easy. Some of them get more complex. These I would consider on the easy side. They'll get a little tougher as we go. I want to do a u substitution by these. How many of you, if you looked at the square root of 3x plus 17, you might be able to find that integral, but you know it would be very difficult. You might be able to think it through, but you know it would be really hard to think it through. Agreed? So, this takes the thinking out of it. What's the part that's inside or complicated? 3x plus 17, everyone agree? So I'm going to let u equal 3x plus 17. Now on your homework tonight, I think it's structured this way. I do not care where if it's in the right box. or dx, sorry. I would probably rearrange that just for helpfulness on solving that. That is the 1/3 the integral of u to the 1/2 power. So we've taken a very complicated integral and changed it into a very easy integral. You see how that u substitution works? So it takes a really complex integral and makes it easy. That's the whole point of the u substitution. And so how do I integrate that? I raise the 1/2 to a power, so 1 plus 1/2 is 3/2. And I multiply by the reciprocal or divide by the Newton power, whichever way you want to think about it. So that would be 3. Right. It is, I just have to, yeah. Yes, if you want to recognize it, but we're working it out. So everyone see how I got it? Last step. Don't forget the last step. What is it? Put the x's back in. My integral did not have any u's in it. My answer should not have u's in it, right? Because that's a different problem. So I get 2/9 times 3x plus 17 to the 3/2 plus c. So this is a new thing actually for today and tomorrow. We're working on this today and tomorrow. No, the 1/3 is still. If you got multiply by 3. That makes sense. That's not up here, not here. So when everyone listen to this, check it, right? We're new at this. You did a good job. 3/2 times 2/9 reduces down to a third, or a third, right? But then when we do the chain rule on the inside piece, we'll get times 3. And so the 1/3 and 3 will cancel, taking us back to the original. Any questions about that? You could probably do the next one in your head. Probably. Because we just did the last one. But let's go ahead and do it just for fun, practice. Yeah, a lot of practice is how you want to just go on with that. Okay, never mind. We'll go on to the bottom. Okay. What am I going to let you be on the next one? So what would du be? So negative 1/4 du equals dx. Questions so far? So my integral would be the integral e to the u times what? What is dx? What am I going to replace we'll have you replace x dx with du over 2. You see that? See the x dx? We want the x's to go away. Here's how you pick it out. If the derivative of your u shows up somewhere else, it'll cancel. Okay, write that down. If the derivative of u shows up somewhere else, you all know what I mean by shows up somewhere else. You see the x shows up there? That x is going to cancel because it's in my du. Because it's going to divide out. So if the derivative of u is a piece outside, that's a good thing. So the derivative of your u, if you can pick it out somewhere else, that will help you pick the correct u. Does that make sense? So this is some very forward thinking. Most calculus students aren't taught that. Most calculus students just pick u's and stumble around. But you're a little smarter than most calculus students, so I think we can use some forward thinking to choose the right u yourself. If not, though, what do? You just pick another one. If you mess up, you pick another one. So let's move on. I have 1/2 u to the 5th du, so I'm going to anti-differentiate that. How do you anti-differentiate u to the 5th? We're not getting good at that part. So I get 1/12. What goes where u was? How many of you could have done that in your head? Yeah, right? That's a tough one. The first two we thought, well, I don't need to use substitution, I can just do this in my head. This one got a little tougher. Just does it make sense now that you see the antiderivative? 6 times 1/12 is a half. Times x squared plus 2 times the chain rule, so you would multiply by 2x, 1/2 and the 2 would cancel, and you'd have an x in front, wouldn't you? Work it out. So the next one, let's look. Now the steps I gave you, the pick the more complicated piece, would probably work. Let's try. What's the more complicated piece in the next one? X squared plus 3x minus 5. But instead of doing all the work and deciding if it works, I'm going to kind of check in my head. What's the derivative of x squared plus 3x minus 5?
X plus 3.
That's exciting. That means it'll work. Because that'll make all the x's cancel. So you see what I mean by that forward thinking? We can think ahead. A lot of calculus students can't handle all of that. So if maybe if, I don't know, you think you can? You like it? Because then you can pick the correct u the first time. You don't have to fumble as much. So we'll try it. U equals x squared plus 3x minus 5. So du equals 2x plus 3 dx. Do you see why that's a good thing? Because I'll be able to replace the 2x plus 3 dx all with the du. If you can see that, you can do it that way. I'm going to go ahead and divide and pretend I don't see that, but that's what we're doing. We're trying to get rid of all of the x's. So I'm going to divide 1 over 2x plus 3 du equals dx. It's a little scary when I try to put y'all in my brain. That's what we're doing today. I'm teaching you the way I do this. It's just a little strange. But y'all are a lot more like my brain than most students. So we can try it. If it doesn't work, let me know. It actually hurts your brain, you know. Any questions so far? Good? So, now I can do some replacing. I have the integral of 9u times 2x plus 3 times dx, and what's dx? 1 over 2x plus 3 du. And what happens? The 2x plus 3 is cancelled. really easy integral, isn't it? What is the u squared over 2? So 9 over 2 u squared plus c. What was u?
X squared plus 3.
How are we doing? How are we doing?
You lost it 9,000 squared.
So from here to here?
Yeah.
Okay, so this is the first power.
2.
Raise 1 divided by 2.
Alright.
Do that when you get lost. Ask me questions. If this both times you've asked, it hasn't taken long for me. Totally good. Just ask if you get lost on this stuff. Hey, try the next one. Try the next one. I'm probably gonna have to go outside my boxes somewhere. I'm gonna run out of space. That feel good so far? Your substitution? How did it?
Should we do some of the homework problems so we can go through documents? Why?
You need practice.
Well, we'd be doing them.
You need both. So you feel like you're ready for homework? Like you got it?
It's like I have to go ahead and knock it out.
Try these. Well, y'all did the next one. They feel like they got it, so I'm sending them that farther down. They can get yucky sometimes. But I don't want to just jump to the yucky. We gotta ease it in a little. But that's good that you get it that well already. Good news. So are y'all able, that little trick I taught you, is it working? Can y'all do that? I think that would work for regular campus students. You don't think so? That's your thing. I usually mention it, but I usually don't mention it until a couple days in. I don't teach it that way normally. Normally the way I teach it is you pick the more complicated one. But that's so vague, you know, which one is more complicated. So what did we pick as our u? X squared plus 1. And is it going to work? What's the derivative of x squared plus 1? 2x. You see the x at the top, and that x are going to end up canceling. It's great news. Or at least we think. So we're going to try. So we do the derivative. Y'all all okay on that part? Any questions so far? Now, did anyone try taking the whole square root? It got awful, didn't it? So that's what regular calculus students do because they go more complicated, the square root's complicated. But that derivative's so complicated it doesn't show up again. Does everyone see what I mean by that? So if you had tried it, what do? Try again, right? Yes, on that try. Then you try again. When the derivative gets so complex that you know there's no way it's up there again, that's when you go, okay, let me pick a different piece. Does that make sense? And so this piece, let's see, I get the integral of x over the square root of u times 1 over 2x du. as it sits. So I've got 1/2 square root of u du. So what am I going to do to make that integral doable? Good. Make that u to the negative 1/2 power. Change that to 1/2 integral u to the negative 1/2 du. Then I can add 1 to the power and all that fun stuff. So 1/2 plus 1, negative 1/2 plus 1 is 1/2. So I get 1/2 times u to the 1/2, and I'm going to divide by the new power, which is multiplied by the inverse. So multiplying by 2 plus c. Turns out that 1/2 and 2 cancel, and I get x squared plus 1 to the 1/2, or you could do square root of x squared plus 1/2, either way, or plus 1 plus c. Would you have seen that one without a u substitution?
Yes.
Without a u substitution? It's impressive.
Alright.
Any questions about that one? Okay, what about cosine times sine? I would argue that it doesn't matter. Why? The derivative of sine is cosine, the derivative of cosine is negative sine. Work with a negative constancy. Sure. So we're going to let u equal sine x. Now, if you did not know the little trick I taught you, on this one, neither one's more complex, you just pick one. Just pick a part to call you. Hopefully it works out. We cross our fingers. In Cal 1, calculus 8b, I get to say this is the only integration technique we know. So you just pick a u and you just go on faith, like a leap of faith. You know it works because that's all you know. You'll need to know a little more than that because you will have some other integration techniques. So if u substitution doesn't work, you'll need to go, okay, I don't see a u that's going to work here. Maybe I'll have to try something else. The only other one you're going to learn is integration by parts and then partial fractions. Those are the two later that we'll learn. Not this chapter. I'm not going to increase your first integration chapter. Same first chapter, but later you will have more options. How are we doing? Say that again. Well, technically it's du over dx equals cosine of x. So the derivative of sine is cosine of x. So we let u be sine of x, and we take the derivative of u with respect to x. And then I'm going to move the dx over because I've got to get it by itself. Does that make sense? Yeah. Okay. So du over dx equals cosine of x. So du equals cosine of x. Any questions on that so far? And then I made the dx by itself even. So I get 1 over cosine of x du equals dx. Any questions so far? You can quickly glance here when you get this cosine of x dx. You see the cosine of x dx are all going to be replaced with du, so that's good news. So we'll just check. 1 over cosine of x times u, because sine of x was my u, 1/2 u squared plus c. Am I going too fast? Am I going too slow? Good. 1/2 sine of x squared plus c. If you had worked this the other way, you actually would have gotten a little bit different answer, but they would have been equivalent. Would have been trig identity.